now let's return to a familiar example from before, where we have two particles um, that collide. So we have particle 1 traveling faster than particle 2, so eventually we have a collision. And then afterwards we're going to be left with particle 1 with some lower velocity, particle 2 with some greater velocity. Which means that the momentum of particle 1, the new momentum, is equal to its initial momentum minus the impulse, minus the momentum that it transferred to the second particle. Similarly, the second particle is going to have a new momentum that's its initial momentum plus the impulse, the amount of momentum that it got from the first particle. Well, let's look at what this means for the system. So if we have our initial momentum is the first momentum plus the second momentum. After the collision, we have the first momentum minus the impulse plus the second momentum plus the impulse, right? Because the impulse is actually the same, right? Where all of the momentum that particle 1 gives up goes into particle 2. So the impulses cancel out, and we see that even though there was an interaction inside the system, the total momentum of the system and of the center of mass didn't change at all. So what that means is we can have some object like a baseball, and we can take that baseball and we don't care about all the particles, all of the particles that make up the baseball. They can be bouncing off of each other, they can be interacting, but that's not going to do anything at all to interfere with the velocity and the trajectory and the momentum of the entire baseball. And that's actually pretty astonishing because it didn't have to be this way. We can imagine a universe where, all of the particles that interact in something, interfere with what the entire system is doing. Meaning that we can imagine all of these electrons bouncing off of each other, and so the baseball, when the pitcher throws it to us, would seem to wobble it in all sorts of different random directions, just like the random motions of the atoms that make it up. But the interesting part is that doesn't happen. Everything internal cancels itself out. So the important part is that internal interactions do not affect the system's momentum. Okay, this again makes physics and engineering much easier, because if we had to try and calculate things in that world where all the internal interactions don't cancel each other out, you can imagine how much more difficult that would make our job as physicists and engineers when we're actually trying to calculate things and build things. But fortunately, nature and our universe was kind to us and didn't make things quite so difficult.